Welcome to Mindcast, the podcast where we dive deep into the fascinating world of artificial intelligence and machine learning. I'm your host, Will, and today I'm absolutely buzzing with excitement to share my experience at the Weights and Biases Fully Connected Conference 2025 in London. This was my first WandB conference, and let me tell you, it was an eye-opening journey into the cutting edge of AI development. For those who might not be familiar, Weights and Biases, or WandB, is the industry-trusted platform that data scientists and ML engineers rely on to track, visualize, and manage their machine learning experiments. Think of it as the backbone that helps teams build better AI systems faster and more reliably. The conference took place at the stunning Convene Sandcroft Meeting and Event Space at St. Paul's in London. And over the next 12 minutes, I'm going to take you on a journey through 2 incredible days of workshops, keynotes, and networking that really showcased where AI is heading in 2025. Day 1 was all about hands-on learning, and I chose to attend the agentic AI applications track. Now, when I say this workshop was well attended, I mean it. We're talking over 200 people packed into the room, all eager to learn about building AI agents. WandB provided 3 collaborative coding projects that walked us through their tools, from basic agent development all the way to creating sophisticated research agents. Here's where it gets really interesting. The final project involved building what they called a deep research agent, essentially an AI system that could take a topic, break it down systematically, and produce a comprehensive research report. But the fascinating part wasn't just what it did, but how it did it. The key insight here is something I'm calling perception as a function. Instead of just feeding an AI model information and hoping for the best, these agents use callback functions, essentially tools that the AI can choose to use during its reasoning process. What blew my mind was that some of these tools didn't even return data to the model. Instead, they forced the AI to think step by step. For example, one tool was simply called planning. When the AI used this tool, it had to create a structured plan before diving into research. Another was called thinking, forcing the agent to pause and reflect on what it had found and whether anything was missing. It's like giving the AI a methodical thought process rather than just raw intelligence. This approach connects to something called BDI architecture. That's belief, desire, and intention, which is a cognitive framework that transforms AI agents from simple chatbots into what I describe as control script executors. These agents can operate continuously and proactively, making decisions based on their beliefs about the world, their desires or goals, and their intentions or plans. But here's the crucial point. This power comes with significant risks. This architecture creates what's known as an indirect prompt injection attack vector. Essentially, when you give an AI agent the ability to perceive and act on the world through these tools, you're also opening up potential security vulnerabilities. An agent's finite context window can become overwhelmed with information, potentially degrading its reasoning capabilities. The solution isn't building bigger, more complex single agents. Instead, the future lies in what the experts called turnless, asynchronous, event-driven multi-agent architectures. Think of it like having multiple specialized AI assistants working together rather than one super intelligent but potentially vulnerable system. Day 2 shifted gears entirely, focusing on real-world applications across industries. The morning kicked off with major business news: CoreWeave's acquisition of Weights and Biases. CoreWeave started in 2017 as a cryptocurrency mining company, but pivoted in 2019 to AI compute services. Their revenue exploded from $16 million in 2022 to $1.92 billion in 2024, with projections exceeding $5 billion for 2025. What makes this acquisition strategic is that CoreWeave now controls the entire AI development stack, from massive compute power for training models to the experiment tracking tools that WandB provides. It's vertical integration in the AI space. The industry speakers that followed painted a picture of AI adoption that's both exciting and sobering. Sonder Timner from GSK shared compelling examples of AI in pharmaceutical development, where regulatory policy is often the biggest barrier to innovation. GSK lobbied to replace one human tester with AI, in cleanroom contamination testing, maintaining human oversight while increasing efficiency. Their small-scale tests looked promising, but deploying across thousands of cleanrooms revealed edge cases their training data hadn't captured: varying light levels, damaged lenses, and image corruption. The lesson here is that AI succeeded in a hybrid model. The combination of human expertise and AI monitoring reduced detection time and increased testing frequency without compromising quality. It's a perfect example of augmentation rather than replacement. Festo's approach to AI experimentation was equally impressive. They invest 6 months and $15,000 in equipment to explore how machine learning can improve their automation processes, using reinforcement learning to teach robot arms to clean 3D printed parts after sintering. Using NVIDIA's Isaac Sim for initial training, they expanded their model's capabilities. But as their presenter noted, real-world experiments are much more challenging than simulations. When they took their robot to the factory floor, they discovered how many variables the simulation hadn't captured. This theme of simulation versus reality came up repeatedly throughout the conference. It's one thing to train AI in a controlled digital environment, but deploying it in the messy, unpredictable real world presents entirely different challenges. Learnocity's Sean McCrossan presented their journey building robust LLM evaluation frameworks using WandB's Weave tool. As a company providing assessment APIs to educational platforms, they faced the critical challenge of preventing AI hallucinations in educational content. Their solution involves continuous evaluation, extending beyond initial testing into live deployments. Zenseact, Volvo's self-driving car division, shared their evolution from traditional rule-based systems to a unified neural network approach. They're harvesting data from thousands of cars worldwide and using vision language models to automatically label training scenarios. Their entire pipeline runs at 15 frames per second on modest hardware, showing how practical AI systems are becoming. One of the most charismatic speakers was Ali Sayed from Denmark's AI initiative, presenting their supercomputer, Geffion. Ali characterized our current moment as our generation's space race, and he's not wrong. Geffion started as the 21st fastest computer in the world and has climbed to 8th place, delivering 66.6 petaflops per second. The practical applications are staggering. They've reduced weather forecasting time from 6 hours to 2 minutes and achieved 100 times speed-up in quantum simulations. But what really caught my attention was Denmark's commitment to providing WandB's workbench to all Danish citizens for free, encouraging their entire population to learn AI tools and skills. This speaks to a larger trend of national AI sovereignty that we're seeing across Europe and other regions. Countries are recognizing that AI infrastructure and capabilities are becoming as strategically important as traditional military or economic assets. The final presentation I want to highlight came from Harry Kopak at the AI Safety Institute, focusing on security vulnerabilities in agent-based architectures. Harry's work on sandbox evaluation tools really drove home the risks we discussed earlier. ASI has developed open-source tools called Inspect that allow researchers to test AI agents in controlled environments. Harry shared some frankly terrifying examples of agents that issued destructive commands like RM-RF, essentially trying to delete entire operating systems. In some experiments, the AI was aware it was sandboxed and attempted to break out of its constraints. His message was clear: be really careful with the tools you give your agents and always sandbox your evaluations. You simply cannot trust AI outputs implicitly, no matter how sophisticated the system appears. This resonates strongly with the earlier discussion about BDI architectures and security vulnerabilities. So, what are my key takeaways from this incredible conference? First, we're at a genuine inflection point in AI development. The question has shifted from should we use AI to where can we use AI, moving from experimental technology to essential infrastructure. Second, the future of AI isn't about building single, monolithic, super-intelligent systems. We're heading towards specialized, collaborative, multi-agent architectures that work together more safely and effectively. Third, the gap between simulation and reality remains one of the biggest challenges. What works in controlled environments often requires significant adaptation for real-world applications. Finally, security and safety considerations need to be built into AI systems from the ground up. The power of modern AI agents comes with genuine risks requiring careful management. The networking was exceptional. There's something special about being surrounded by people pushing the boundaries of artificial intelligence. I'd highly recommend attending next year's Fully Connected conference. That's a wrap on today's episode of Mindcast. I'm Will, and I hope this glimpse into AI's cutting edge has been as exciting for you as it was for me. Until next time, keep exploring the fascinating world of artificial intelligence.